recording on. So welcome back to our second day of Python, doing some language processing, some visualizations. Today the first thing we will look at will be Nltk Library, which is one of the most popular natural language processing libraries in Python, quite a few capabilities. And I should mention about the assignment. Again, there is a link. In the day 1, part 3, there is a link at the end for the assignment. We only have 7 submissions. So this is the link here. If you go here in the day, if you click on the day 1, part 3 at the end, remember there's the assignment link. So I think I'll give the mic to Uldis, and he will talk about Nltk.
All right.
I'll open it up meanwhile. Right? I will open up in the Colab. So day 2, part 1, those who are using Colab can open directly. If you are using it, let's open it up also maybe on the also Anaconda. If you're using Anaconda installation, you need to find notebooks. Right? You will need to download the latest version, of course, of this notebook. And we'll open up Nltk introduction, right? 11.
Yes.
Yes, that's the one we are opening up. So for most part, the instructions should work the same across these two. Right, okay, I'll leave the Colab, it's probably a more popular one. Right, so, okay.
Okay, so let's use this notebook to explore natural language toolkit. As well as mentioned, it's a popular or the most popular natural language processing platform for Python. Let's learn more about it. I will be using Google Colab, but you can also use a locally installed version. Here are some links to Nltk, where you can explore Nltk itself. You can find its library documentation, and there is also a wiki. So there's a lot of information that you can find on the Nltk org site. So this is the documentation, more technical documentation of Nltk packages, the parts that are included in Nltk. So for example, sentiment package that you can use to do sentiment analysis. The wiki looks like this. So again, you can look for answers to your questions, to find projects that use Nltk, and so on. And then another very useful resource is the Nltk book called Natural Language Processing with Python. And this book is available online for free. You just need to open the book, or we can open directly to say chapter 1. This, well, it doesn't let me enlarge text, but
Control plus, maybe. Control, yeah.
I did try it.
No?
It didn't work.
I mean, don't you? This is resigned. Resigned. Use that.
Okay.
Yeah.
Yeah. Right. So Nltk book, and we can't cover all of Nltk in just one lecture. So this book is a really useful resource. We'll look at some parts of the book, namely the introduction, language processing, and Python, and also some bits more like processing raw text. But there's more that you can explore through this book. And actually, the way the book is written, it gives you both an introduction to Nltk and also introduction to Python at the same time. So it shows you what happens if you make an error, and so on. And this is chapter 1, language processing and Python. So the introductory bit to Nltk, and we will also explore the introduction to NLTK, but we'll skip those parts which are about Python in general because we learned that already yesterday. All right, so let's start. I hope that you can hear me now. First, some configuration. And we have to tell Google to run this notebook, so it takes some time to launch the Google Colab instance, and now the command is executed, so matplotlib notebook will be useful for visualization later on. Let's go to the introductory part of NLTK, and first we need to import it. So let's import NLTK and pandas as well. That will be useful later on. And let's check NLTK version. Google Colab has NLTK version 3.7. That's good. If your NLTK version is lower than 3.4.3, then please update it. So here is a command how you can do that in Anaconda. Google Colab already has a recent version of NLTK. So first thing that we'll look at is nltk.text. That is a simple helper for loading and processing text content. It looks at text as a sequence of words or of string tokens. So we can use it for this initial exploration of text like we are doing now. So there is documentation for NLTK text, and it lists what we can do with it once we have loaded text into NLTK. So where is it? NLTK text. That's here, but we have to.
There's underneath submodules. I guess it's NLTK text. No.
NLTK text module, and then we can learn what we can do with NLTK text instance. So data that has been read in this NLTK text helper. So we can ask for tokens and so on. Actually, in Google Colab, we can also just look at the methods that will be offered when we read this text. So here is a simple list of words, of text strings, and we create an NLTK text object by passing it this list of tokens. There seems to be an issue with updating NLTK version
locally, right?
For local installations. We'll look at what can be done to help with that.
Do you want? I could take a small break and we can show it here on the screen. I guess.
Okay, let's do that. So
you could do this So yes, let's take a slight detour for those who are using a local Anaconda. It will be, you go to your Anaconda, right? Here we go, Anaconda. Here we go, right? Or navigator, right? And we go to our environments here, right? And let's put what we have installed, right? We search packages, NLTK, and I have 3.65 installed here, right? So you could do, if you don't have a version, check your version here. Right. Again, if you are over 3.4, then you are fine. Again, most things will work. Some of the newer, fancier text generation options will not work if you have an older NLTK. If you don't have an NLTK at all, right, you can check all packages, right, and you'll have a huge list update index. I think there's only one NLTK, so you can search for packages here and install locally using this environment manager, basically. Again, you can update. So let's see, question now is you can update index, and if you need to update, you would need to go to a command line, actually, like the command we mentioned, right? So the question is now, is everybody's version, does anybody have version under 3.4? No, everybody has. Which one? 3.61. Okay, so you're fine then, right? So if you are over 3.6, you're certainly fine.
3.4 is fine.
Yeah, 3.4 is fine. Yeah, so you'll be fine. So again, that's a technical issue. We don't have time, I guess, to deal with that right now, right? So yes, yes, so that's a possibility. If you don't have it at all, you can install it like through here. For example, you can install, let's say, pandas. We can check pandas version, right? We have a lot of pandas here related packages. We have pandas 1.34, for example, here, right? You can see it. So if you need something installed, you look for it and you click, right, and you apply, right? You press apply. It's quite nice, right? Okay, but let's detour for those who are using a local environment. Let's go back to our.
Well, while you are at it, maybe you could install Simplem package. Just try doing it.
Okay, yeah, that's a good idea. Let's do it locally first. See if this is a package. All this will be using a little bit later on. So I'll go to my environments, and what's the name? All this Simplem. Simplem. Let's see if it exists. Simple. I'll do lemma. Is it lemma? No?
Oh, lemma with 2 M. So it's not available here in Anaconda.
In Anaconda, but that's not the end of it, of course. We can install it using pip, which is a big package manager which includes all the packages. Yeah. However, again, we'll be using Colab, we'll install it using pip when the time comes. So that's not an issue. Because Conda provides a curated list of packages, meaning they have been verified, they have been made to work on slightly more, more organized. But of course, downsides you don't always get the latest and the greatest. But okay, so going back to our Colab, right? There's a question from, will we have videos? Yes, the videos will be. I'll add the links. Unedited videos, right? Will be added here to the GitHub. So I'll answer that maybe.
Okay.
Go back.
All right, back to me then. Okay, so let's see where we left off. So first, let's create this nltk.text object. Actually, we have already done that, and we can then print the content of this object like this. So it says it's a text object, and here is some start of the text that we have added to this object. Actually, this is the whole text. And if in Google Colab you press a dot sign, then you will see various methods that this text helper object provides you. So you could look at concordance, common contexts. You could draw a plot of characters of some tokens in the text, and so on. We'll look at these methods later on in this notebook. If you are using a local installation, then after pressing dot, you may need to press tab symbol, and then you will get a list of methods. So in any case, we have this helper object now. We can check its type. So type is nltk.text.text, and now we can look at this object and call its methods. For example, ask how many times the word example appears in the text. So we have this myText object, and we call a count method on it. So we ask this object to count the number of times some token appears, some word appears in this text. Please note that this counting takes place over full words. So we already found out that the word example appears in our text, but if we would look for word exam, then it will be found 0 times. And we can also check if exam is in text in this way, exam in my text, and the answer is false. So you have to search by full words. For example, example in my text, is it true? Yes, it is true.
So could you say it's this my text, this text object type of text is kind of similar to list, I would imagine, more closer to list than a string, right?
It is similar to a list with some additional methods that we can use. Now let's convert some text into Nltk.text object. So first, in order to work with the text, we need to split it into tokens, into words, and then we will supply these words to the Nltk.text object. But first, we need to import Nltk, and we need to download an Nltk dataset that will contain punctuation information that is used for splitting text into tokens. So let's do this. Okay, we have downloaded this Nltk component called punct, and now we can split text into tokens. So first we'll import the part of Nltk that is responsible for splitting text. Then we have some texts that we will work with. So text about Nltk, that Nltk has been called a wonderful tool, and so on. And then we call this word tokenize function on this excerpt. And finally we print the first 6 tokens. Let's do that. And we see that Nltk text works as a list. So we can ask the list for first 6 objects, for example, and we'll see these words. Nltk has been called, then a quote, smart quote, and so on. And now we can call methods on this text object. For example, here is the place where we create this helper object, so Nltk text, supplying it with a list of tokens that we generated earlier on.
All this. Also, question now: if I decide I want to go back to a regular list, so I could just call list a method on this my text too, and I would have a nice list of tokens, just generic one.
So how do we get back to a list?
Yes,
right?
so you have my text too, which is a type Nltk text, right? In our cell. Right, so this is
indeed.
Yeah, so it certainly looks like tokens, but it's not. It's like I said, it's a list with benefits, right? So you want to go you could call it as a list, right?
Yes, if we want to get back to a list, we could. Well, no, sorry. This is a list of tokens. It's already a simple list, I think.
Yeah.
I checked the type of tokens list.
It's a list. Okay. So that's we're fine then. It's just a list.
Okay. Thank you. So in this case, it's just a list, but Valdis' question might be valid here when we create this myText2, which is an Nltk text object. Then a question might be how to get back to a list of tokens from this myText object. So this is Nltk text object. This is not a list. Well, one option could be just converting it to a list. But this text object also has methods.
Let's see if it works. It might work. Yeah, I think it works.
Mm-hmm.
Yeah, it works.
Quick question in general about what tokens are. So if there are 2 dots next to each other, will it separate them out or will it be single?
So,
Not sure what
yes, in this case, it really depends what method you use to tokenize. In this case, it's using Nltk method of tokenizing, and it certainly looks like it's using this word tokenize method. Actually, takes everything off. I mean, it really does split it in individual items. You have you know, let's say 2 dots. I don't see 2 dots here, right? It looks like it splits in single dots. Yeah. You could of course experiment with this. Like the method yesterday, we used regular split, just generic Python method. Of course, it would not really even split the commas or dots or periods from the text, right? This is just a very generic method. So this is more specialized, already tokenizer, right? So depending on your language needs, if you have some special symbols, you might need to modify this. Maybe you have some extra symbols which are not recognized by this tokenizer. Thinks it's just a regular symbol. Right? Maybe some what's long dash, for example, or if we have time, we can later on, towards the end of this session, we can experiment with it.
Okay, I will just check the case. What happens if you have multiple dots? So let's tokenize, split this text into tokens, and let's look at the resulting token list. So 3 dots were separated into a token of its own.
If you have 2 dots.
We could check 2 dots, or we could check what happens if there is not space between a word and these 3 dots. I suppose that then it will create a token like this. But let's check.
It separates them.
It separates them. It's a bit smarter than just doing a Python split method.
But the nice way to use the hyphenated words, the word is together.
Okay, try that one.
An example. For example, far reaching.
Yeah.
Yes.
Yeah. So it's smart enough about this.
All right. Now Nltk also has a lot of language resources, corpora and other resources in this library already. For example, if we are working with examples from the Nltk book, it's useful to download the texts referred to from this Nltk book. And for that, it's not enough to import Nltk. We need to tell it to download these language resources used in the book. And we can do that using nltk.download method, and it downloads quite a lot of resources, for example, WordNet library and so on. So it's done downloading this book collection, and then we need to import. For example, let's import everything from Nltk book.
It would be nice to import them separately, but yes.
And we can see Nltk printing out what different texts it has read. So here is both serious texts such as inaugural address corpus of US presidents, and there's also Monty Python and the Holy Grail. So it's up to you what text to work with here. So let's see. Let's explore some text. So we have text 1, Moby Dick, and we'll also look at text 4, I think, inaugural address corpus. So first let's check the type of text 1. It's nltk.text.text. So it's this text helper object. And we can, for example, count the number of times whale is mentioned in Moby Dick. So that's quite many times, 906 times to be precise. And we can also look at concordance. We can also print concordances of this text resource. Concordance means that a given word or words are shown in context. So it's kind of output centered around this word we are looking for, discover, but you can see various mentions of the word discover within the context of words that are around it. So that already lets us explore, get some feel for the text that we are working with. Same for the inaugural corpus. Here we look at word nation, and word nation is found in 330 matches in this corpus. Concordance method doesn't print them all, it displays first 25 entries here.
So how would we see next 25 entries, or maybe let's see 100 entries? There should be a maybe there's an argument you can add to concordance method, I believe. I'm not sure. That's been
I would expect that there is a parameter that we can use, so text concordance, and how do we look for help here?
It should pick up help, right?
It did. Oh,
yeah, there.
Okay. So it only offers methods
yeah, there's width and lines 25. You see lines?
Width and lines.
So you can how wide do you want to see?
So I hover over it, and then it has parameter lines that tells how many lines we want to show. Now, so it doesn't seem like we can look at the next 25 matches, but we can say that we want to have 50 lines printed.
Also, there's a nice extra method, concordance list, if you want to save the results, which might be useful.
So default is 25 lines, but we can ask for 50 lines.
Discover, we need a keyword. We need the word we're looking for.
Of course.
Nation, I believe, or nation. Yeah.
All right, thank you. And we have first 50 matches of the word nation in context. Now we may also ask this text object to display words that are that appear in the similar context as the word we're looking for. So for that we use text.similar method, and let's look at nation again. So some words that appear in similar context, so where similar words are around it, are country, people, government, and some others, like party. Well, political party, I would guess.
Yes.
Yes, there's a question.
Do you know what kind of technique is used for similarity measurement?
You should probably see that it's pretty well documented. You can go to the page. It should mention what similarity algorithm it uses. The similarity, if you go deeper, the similarity, I think it was somewhere which we use it.
Oh, it didn't jump to where we wanted, so let's similarity.
Similarity dictionary, similar words, context.
I can't answer right away what method it uses, but there is extensive documentation that you can look at. Okay, and we can also look at for common context. So we can supply a list of words to this common contexts method, and for example, if we supply words day and night, we can find contexts in which these words appear both in a similar way. So similar context for day and night is, for example, the previous day, the previous night, one day, one night, the day before, I guess, the day after.
This is a Moby Dick. Yeah.
Yes, that's a Moby Dick text. Here is a side note about lists. So NLTK text works as a list, so we can do everything we could do with lists. For example, we can ask for the index of first occurrence of a word, he in this case, and it's word number 42. And let's check. And word number 42, word with index 42, is indeed he.
And as I mentioned, this is actually the 43rd, of course, because we start indexing from 0. So.
Indeed. And we can look at a slice of words here, for example, words from index 42 to index 52, and we see these tokens. He was ever dusting his old lexicons and grammars. Now, what we can do for further exploration, so one thing we could do is we can visualize the corpus using dispersion plot. So in this case we will use the inaugural address corpus, and we will ask this dispersion plot method to display lines or display places in the corpus where these words have been mentioned. So citizens, democracy, duty, freedom, and America. And here is the dispersion plot that gives us some idea of the distribution of these words, these tokens, inside the text that we are exploring. So we can see that the word citizens has been mentioned throughout this corpus, and if I understand correctly, this is a corpus of many inaugural speeches. So
starting from beginning, yeah, so from the George Washington, or no, and going up towards, I believe, probably end of current presidents. So
What exactly is the x-axis?
that's basically a count of tokens, basically. So it's basically a word, or tokens, right? So you start from 0, would be the first word of the first speech.
Okay.
So
And then the last word.
yes.
Mm-hmm. And assuming that these speeches have been aligned, sorted by time, then we can get some idea how what words have been mentioned at different times. So you can see that citizens have been mentioned throughout these speeches, but democracy has been mentioned mostly at later times. America as well.
Yeah, interesting.
Not so much at the beginning, and then it gets mentioned quite a lot. And duty is more skewed towards the start of the and middle of the speech corpus, but not so much at the end of the corpus. Okay.
You were supposed to draw the graph for me, right? You were supposed to display the picture?
Yes.
Yes.
What if it didn't? Am I missing the library maybe? Is there some kind of library that
I'll take a look, but maybe our artist can look. But are you using your Anaconda installation, right? Local one.
No, I have the visual code thing.
There might be one cell which is not run on notebook, the visualization. I think there is a cell in the beginning we run through. It should work. I think there was a cell.
So at the beginning there was a cell for
Let's see.
configuring matplotlib.
Yeah, this first cell. Yeah, that's the one you should need. You might need to run this, the very first cell.
Also, you can search for dispersion by comma, dot, question mark, exclamation point. It's quite interesting.
Oh, really?
Exclamation marks are very few, but question marks are
Okay.
a lot.
Let's show it. Let's show this. Yeah, that'd be great to show. So this is that text. This is that inaugural speech address corpus. So let's try this one.
Okay, let's do that.
And
So
we could do all punctuation, of course. Check import string punctuation and
well, but we can
I'll
look
just do it by hand. Yeah.
for dot. What else? Question mark.
Colon and
Yeah,
semicolon,
yes.
and then question mark.
Yeah.
3 points. Oh.
That's a good idea.
Question mark and
exclam.
exclamation mark. Okay, let's look for these symbols. Well, dots should be everywhere.
Yeah.
Should be yeah.
Okay, dots are everywhere. It's difficult to see it here. Semicolons are appear throughout the text. Colons more towards the end of the corpus. 3 dots over here appear just a few times. Looks like it's 3 times. And exclamation marks more towards the beginning, and question marks throughout the corpus.
Very interesting.
Okay, it's interesting. in Twitter corpus, if we had one, we could look for emoticons, for example,
Yeah.
smileys and so on. Well, I don't suppose that this corpus here has smileys in it. Probably not.
So yeah, the question is now, how would you save this? Well, the only way, I think NLTK is mostly oriented for exploration. It doesn't have as many tools for saving the results. So here, of course, you just want the picture, you could use a good old right-click, save as, basically. I don't know if there's other way of importing, right? Save image.
Save image as or open image in new tab
Yeah,
and then
that also
do
works.
something.
Yes, you just have image, basically, right? It's just a picture.
But there are other libraries
Yes,
which would be more
Yes,
helpful
yes.
in working with such pictures. But okay, at least it can be saved.
Yeah, in the local version, it just has this download sign.
Oh,
Oh, okay, so it's easier to work with it in the local version, so, or easier to save it. Okay, and here is help for text dispersion plot, which tells, well, what it does. But really, you already saw a demo of it in action. How are we doing time-wise?
we're doing pretty well, actually. We have lots of time, so we'll probably have time to work on our local corpus. This is the English corpus. We'll have time to check. There's no time. Let me check. We have about 45 minutes for sure.
Okay.
50 minutes. We are
Good.
doing very good.
So another thing you can play with, and here I mentioned play because you will be generating some nonsense text. So you can take the text and analyze it and ask NLTK to generate a similar text. So here is help for that function, but it will work if you have NLTK 3.7.4 or newer. So if you have an older version, well, then you just can't run this generation example. But if you do have this text.generate method available, then here is a way how you can generate text.
It mentions what kind of, again, the question is what kind of method it's using. It's using a trigram generational method, a language model, basically, and it checks what's most common word after these three words, and so it keeps generating. Sort of like Markov.
Putting those words in the text?
Yeah, it looks.
Word before.
Yeah, it starts with these three words, right, on, then it keeps building up, basically, right. It's not as smart as one of the newer. This is just very basic language model. So let's see, it builds an index of n-grams, of trigrams, and then starts building it up. Again, of course, it's not right. So it's pretty not as good as GPT, of course, right. It's but.
Why do we need this? Why?
That's a good question.
Okay.
That's a good question. Yes, it's like okay, it prints something similar to the text, but from research perspective, probably we don't need it really. It's just a nice thing you can do that is included in this library, and we could look at another text, for example.
Let's try the inaugural address, maybe.
Inaugural address is text 4, and which is Monty Python.
Let's try
it's
Monty
text
Python.
6.
Yeah, let's try Monty Python.
So let's just look at the various. So 4 and 6, right?
Maybe it could like generate temperature relations with good
Yeah.
according to the text of
Mhm. Yes. And those who have played with GPT models, they also know that often it's complete nonsense. You have to sort through the answers and pick and choose. You still need human creation.
So here is, well, we may need to choose a different seed words, but here it already mentions parliament, freedom, and so on. And if we would look at text 6, don't generate. Yes, maybe we need to.
Knights who. No, government knows something. Knights who say. Right? Right, okay, let's see.
Okay.
Let's see if this happens. What happens now?
Still, too many
Too much
punctuation. So this didn't work. Well, it says don't say "ni" to that old woman, but well, so that's Monty Python for you.
Yeah.
And back to Moby Dick. Knights who say what?
Nothing will happen.
Say a single flying fish are lungless and cold. So Moby Dick is better for generating such texts. But really, that's just a fun excursion to generate.
Yeah, you could. Yeah, Link maybe has more about this language model.
Yes, this link has more information.
It's an Ngram model, so it's not very, like I said, it's not relatively basic.
And you can supply different seed
Seeds,
value to get different results. So here it explains what is this generate is doing. But okay, not that much practical applications, and there are smarter ways to generate text, random text from existing corpus. That's more in the machine learning field. It's GPT-3, right?
Yes,
so
of course.
All right, so that was generate. And here is some help about the generate method. So length, text seed, and random seed tells this method how to generate this text. Now we have our own corpora that we may work with, and we already looked yesterday for ways how we can import our corpora, and let's see how we can convert this a corpus into NLTK text object. So first, let's use pandas. So pandas read CSV method, and let's give it a URL where to find data. This should work both for local installation, Anaconda, and for Google Colab. So we look at the shape of the data frames that we have read, and we see that it has almost 5,000 rows and 4 columns. df.head method shows us the first records, so the first 10 records which have rows for columns for language, source, date, and text itself. Now we can sort these articles by date. So sort data frame, pandas data frame dot sort values method, and let's sort by date. Date is a string, but it will still work because it's in the order of year, months, and date. So here we have a sorted list. Currently that's a data frame, so a pandas data frame. Now we will use this data frame to do something with our text. And here is another sub-lecture on concordance and collocation from a notebook by Nathan Kelber, which we adapted under Creative Commons license. So we looked at concordance already. That's a way how you can look at some words in context. So one word or a number of words, a sequence of words. So let's first we need to get to this text object. So first let's get from our data frame to text. And that's what we do in this cell. So we convert data frame.text column to a list. And then when we look at the length of this document's variable, it says it has 4,999 records. Or yes, that's a list. Documents
So yeah, it's a good idea how all this is showing. Always, if you're not sure, use type and check what kind of object, what kind of data you're working with. You know, if it's a list, then you know what to do next.
Then we can work with it as a list. So we can look for first 3 documents, and notice that here we only have text. We don't have those date and so on columns. And in this case, for this analysis, we will just join all the documents together. It might not always make sense, but in this case it does.
Because we also sorted them before by date, so we'll have a chronological order of this, similar how the inaugural address.
So all documents variable will be all the document lines, all the document items of the list joined together with the new line character. So we join them together in one large text variable, text value, and check its length. So its length is 1.4 million characters. And now we can look at first 100 characters and see that there is some text, a new line, next snippet of text, and so on. Now, in order to work with it further, we will also change these words to lowercase, so that we don't get these variations of capital letters or lowercase letters, that all the words will be in lowercase. For that, we need to download Punctuation resource.
I don't think we didn't download.
But we did already download it.
So you can comment. Yeah, it's.
But well, there's no harm in downloading it again. So what's important is we change the string to lowercase, and then we use Nltk word tokenizer to change this text string to tokens.
That's the important point, that this line, because if we could have used regular split, which is be fine, but then we wouldn't have these these commas would be still with the word, basically. So that's why Nltk word tokenizer is smarter. It's a bit smarter.
And when we run it, we get Nltk text object in the text variable. So all the tokens have been read into this Nltk.text object. And we can verify its type, and we can look at concordances, for example, concordance for word Riga, or Riga with a long I. And we see some context in what the word Riga applies here. So there's a basketball team, there's a road, Riga, Jelgava, and so on. Or text Riga is Riga. that's well, you can't dispute that. All right, so that's the concordance. So first 25 matches, and with 80 characters to each side. In this case, we can also create concordance and increase the number of characters to show for the context and the number of lines of matches that are shown to us. So there are some parameters to concordance that we can change. We may also want to save this result in a variable.
I think concordance list should do it. I think so. Let's maybe try a new cell code. Let's add a new code. I don't know if it covers this.
I think it's in one of the further cells.
Okay, so let's keep going. Yeah, yes, okay.
Let's look at concordance of multiple words. So Latvia is, or Latvia ir. And again, no big surprise, we are getting context of this phrase, Latvia is. So.
What is the difference between this and just stating in quotes Latvia ir with a space?
Let's check.
You have to do it with a comma.
These are two different tokens, so let's see if it will work. So what's the difference? First, okay, let's check. So Latvia ir. All right. So it says no matches because it's looking for tokens and there is no token Latvia ir. So that's why we need to supply a list if we are looking for multiple tokens together. If we want to save this concordance for later analysis, we can use the concordance list method here, and instead of printing concordance to the screen, it will return the values that we can save to a variable. So output list equals the concordance list of Latvia is, and we get the first 50 matches. Now the type of this output list, it's a list of concordance lines, and we can look, since it's a list, we can look at item 0, so the first item, and we can look for the content of this line. So here is Latvia is, and that's the context in which it appears. And
on a, oh, do you want? Well, you could use this line. I believe it's just regular string. I believe this. Yes. So you could. So this line, right, which Ulrich just showed, that's just a string. It looks certainly looks like. So we'll see next cell. I think we'll see how we can save this on to the file, and then we can do whatever we want with this. So it's like sort of intermediate object, basically, this concordance line.
So we can look at what methods this
yeah, what it offers. Nothing.
Which it offers, or I could try to look for help on that object, but it might not work. Oh, what happened? Let's check for help, but I'm not sure if it
may
will
not
work.
pick up on the type. Oh, these are all these built-in ones. Nothing. So
yes, you. It's not very helpful. It's something similar to text object, but it doesn't. It has some. It has some
queries.
Some information. So there's line for the whole line, but we can also look at the query and left and right part of it. So let's check. So that was help for this concordance line object. And what if we wanted to explore this object? We could look for the left or right side of it.
Okay, yeah, it splits. Okay, so it's actually, so left is a list of everything to the left of the target of the.
Right is everything to the right. And query should be the queries that
words you're looking for.
That we ask.
Should be the list of 2 words, I would imagine.
Latvia
here. Actually, put them together.
So we can do something with this list of concordance lines, and we can save it to a file. We already looked at saving to files earlier on, but well, here we do that again. We open a file for writing, and we will use UTF-8 encoding, as we should these days when everything's Unicode. And then for each row in the output list, we just write a row line and a new line character. So after executing this command, we should be able to find my concordance txt in the current directory, and here we can see this saved concordance list. Okay, what else can we do? We are nearing the end of this block of NLTK introduction, but let's look at dispersion plots again. So, as you saw before, we can get dispersion plots for example, of Latvia basketballs, footballs, violations. Actually, I think we should say Latvia in lowercase, since we lowercased everything already.
Yeah,
and that should change the result.
Yes, quite a bit actually, yes.
So we see the mentions of Latvia, basketball, football, and violations or election throughout this text corpus. But so you will notice that the word basketball appears in this text just a few times, even though basketball is pretty popular in Latvia, I guess.
Yes.
So let's check why is that so, or if it is so. And for that we might want to normalize this text further. So here is a simple cycle that goes through items in text, so tokens in text, and prints those tokens which match the string basketballs. So basketball in nominative in Latvian. But in Latvian we have these declinations, right?
Yes,
yes.
Declination.
And this word might appear in different declinations. So let's import a regular expression library and modify our printing code so that it uses regular expression matching technique, where will look for all the tokens that start with text basket and then has any number of additional characters.
So 0 or more.
0 or more characters.
Yes. Again, since this is a token, it will end at some point. It won't go forever, right? Because it was already tokenized.
And it's.
Excuse me? Yes. That's raw, right?
Yes, it says that this is a raw string. In this case, we could have done without it, but usually for regular expressions, you want to have this R in front of a line. It says this is a raw line. It means that, for example, if you write /n here, that it will not be interpreted by Python interpreter, that it will just appear exactly as it's written.
Otherwise, with regular expressions, it would slightly conflict with the Python strings, and you have to write double escaping. You have to start double escaping, and your regular expressions would look really, really messy, and would be really hard to follow. Even though they are already hard to follow if you have a longer regular expression. So yes, these are relatively simple expressions. So raw helps us to write basically simpler strings.
And here you will notice that we have many more mentions of basketballs, but in slightly different forms, so in different declination. So there are different declinations of the word basketballs. Basketballa is actually more popular, basketballu here, and so on. There's also word basketballist, so basketball sportist, and those also appear in different declinations. So just looking for word basketballs doesn't help to find these words. So let's look at normalizing text. You can find additional information about normalizing in the Nltk book. So right here. So it's chapter 3.6, normalizing text, where it looks at stemming and at lemmatizing. So ways how to remove affixes from words so that all the mentions, for example, of basketballs appear the same.
However, this is for English language, of course.
However, that works for the languages that have been included in Nltk or in a particular library that you are working with. So we may want to strip off these affixes, and the task of removing these different affixes is known as stemming, that we leave only the stem of the word. But we can go a step further and look for not for the stem, but for a dictionary word that is kind of a normal form of the word that you are looking at. And that is called lemmatization. So NLTK offers both stemming and lemmatization, but it's limited to some languages. So Latvian is not one of them. Neither is Estonian. I don't know about Ukrainian.
Let's check. Can we check with that package, that link you provided there? Can we check the package link? I think.
Well,
I
yes.
think Finnish was. I think Finnish was included, if I'm not mistaken. I saw some Finnish support on. I think there are about 20 languages supported.
Well, this nltk.stem package has a number of methods, including WordNet lemmatization method. But here are different methods. Some of them are, for example, for Arabic language. And we can look at NLTK, for example, Porter, Stemmer, or Snowball Stemmer, and some of them might mention languages that are supported.
Oh, yeah.
So the Snowball Stemmer supports Arabic, Danish, Dutch, English, Finnish, and so on. Not Latvian, not Estonian, nor Ukrainian. So let's look at stemming, but just keep in mind that it won't always help to use just the Nltk library. But let's look at English first. So here is some raw text from Monty Python. And let's tokenize this text. And then let's use Porter Stemmer to stem this text content. And we see that we now the text, first it's in lowercase, so Dennis is Denny now. Well, maybe that's not that helpful, but here are the different here's the result of stemming this text.
It certainly looks like stems. These don't look like lemmas. There's missing, because yeah, it's just stems.
Yes, it's not full words. Distribute, sword, basic, govern, and so on. Let's try the WordNet lemmatizer now, which uses a WordNet dataset to get not just stems of words, but normalized forms of words from the dictionary. So let's import WordNet lemmatizer. Then we launch it. So we create a new instance of WordNet lemmatizer. And for t in tokens, so for every token, we will print the result of lemmatizing this word, and at the end we will add a space, so it will not be every word on the same line, on new line, but here's one line with text. And these already look like, well, they are proper words, so strange, woman, lying, pond, distributing, sword, and so on. So this is more useful if you can lemmatize the text. But we already noticed that the text,
Yeah,
we are
we're also
getting
getting
an
error
error
too.
as well.
So this WordNet lemmatizer doesn't like something.
The WordNet lemmatizer needs a language resource. It already tells you what is needed to be done.
Okay, so we can do that in above.
So sorry for this.
We can check above. We can add a cell above.
We will add a cell, a separate cell here, where we will download this WordNet resource. So we have downloaded.
It's very quick, but yes. So NLTK has a lot of extra resources you might need to download, because again, if you did everything, if you download everything, it will take. Again, it might not be needed. It's just to save time and memory.
Mm-hmm. Maybe you can write in chat this command to download. Yeah, you cannot copy paste. Sorry. Valdis will copy this lines that you need to add, but actually, if you looked at help,
okay. All this, let's run it first, see if it works.
Okay.
That works, and second line, it should work now, right?
Yes, it works now.
Okay, so if you
So you needed to download this language resource, nltk.download. All right, and now it works, and we can lemmatize our text. And so, did you manage to copy it?
command go plus
So this is the resource to download.
or MW 1.4, right?
Yes. Okay, so the command to run is also in our chat.
Yes.
Alright, so that was lemmatization. But what can we do if our text, the language of our text is not supported by NLTK? Well, thankfully there are other libraries that can help us, and one of them is called Simplemma. There's a link in the sorry. So Simplemma, there is a Simplemma library. So from Simple Lemma, and it allows you to lemmatize text in 38 different languages. So if we go further, here it mentions the language is supported by Simplemma, and you can notice that there's many more languages than NLTK supported for stemming, and it includes, yes, sorry, it doesn't have Estonian, but it has Latvian, Lithuanian, and Ukrainian as well. So 2 of the 3 languages for that we have our corpora in are supported by Simplemma. So it's a useful library to have. You can read its documentation here, and there's also an article about Simplemma here on the blog about corpus linguistics and NLP. So let's try using Simplemma. It might not work right away in your local installation or on Google Colab, because if I try to import Simplemma, I will get a module not found error. So module named Simplemma was not found. We can fix that using Python pip utility and tell Jupyter to run a command line command pip install Simplemma. This should work, but let's check if it actually does work. And after installing Simplemma, we should be able to import it and work with it. So how is everyone doing? Is it working for you? Okay.
I just found that the notebook was updated, so I have yesterday's version. So now I'm trying to download.
Yes, the notebook was updated today, indeed.
Yeah, I managed to copy everything over.
Yes, sorry. We should have mentioned that updating is necessary for the notebook. Any more questions, comments? Okay. So yes, that's the command to install additional library, Simplemma in this case, and it takes this library from a Python module repository. So there is a large repository that has lots of libraries for Python.
Usually it's PyPy.org show. It should be about almost 400,000 projects. Oh, here you go.
So this is this Simplemma package in this library, and if we click at the PyPy Python package library main page, you can see that there's 390,000 different projects, different libraries for Python. So there's a lot that you could install and work with.
But of course, it's 80 or 90% rule. Of course, as you know, most of those are just most of those actually probably student projects. It's not technically that complicated to submit your own package. So I would say about 20,000 are the actual serious packages, libraries.
Mm-hmm.
So
okay, and now importing Simplemma works, and we can go through our list of tokens again and print a lemmatized version of these words using Simplemma library. So sl.lemmatize, and let's tell it that we want to work with English. And again we get a result which is probably similar to lemmatization using Nltk. So for English you can choose which library to use, Nltk or Simplemma.
Like I said, yeah, for English you have a wide variety of choices. There's many different tools, so it's like a Swedish buffet. But for other languages it's much more limited. Yeah.
So not all text is in English. And let's build a list. Let's build a list of lemmatized tokens using first we will use this text, which was our Latvian text. So text with 231,000 characters. So that's the corpus that we loaded previously.
Question: is it characters or is it actually tokens or words? I believe. I think it's words in text, right?
300 and.
Yeah, commas too, of course. Yes, yes.
Okay, let's look at what text is. So just a reminder. Let's look at type of the text object.
I believe it's Nltk text, which is
NLTK.
basically like a list with extra methods.
Mm-hmm. So len of text will probably tell us the number of tokens in this text. And all right, so it's not characters, it's 231,000 tokens. Mm-hmm. And now for these tokens, so for every token in this text, let's lemmatize the token using Latvian language, and let's build a list of these tokens. So at first we have an empty list, and then we add every lemmatized token, every lemmatized word to this list. And then we can look at first 20 entries in the list. Kad, mas, nauda, veselība, and so on. And now we can build this nltk.text object from our list of tokens. So that will be text new. And let us display a dispersion plot for languages Latvia. In this case we could leave it with a capital L, basketball, football, and elections. And as you can see, for example, here in the line for basketball, if previously we had just 3 mentions of basketball, now in this plot we have more mentions. So these words have been normalized, lemmatized, and we can find them more like a larger number of words disregarding their variations by declination and so on. So that was Simplemma library in action.
So does it support Estonian, Ukrainian?
Not Estonian, but at least it did not list Estonian. You could check.
Try EE maybe.
Try EE. Well, not for Latvian texts.
No, of course you will need different corpus, yes.
We could try, but well, it does not support this language. If that is the code for Estonian. ET? I'm not sure. So we need to stop.
What's happening is we have 230,000 tokens. It's going through and printing for each token. It's bringing an error It's trying to do it 230,000 times, right?
Yes, that was not the best idea.
So we have to press the stop button, right?
brightest idea.
Interrupt.
And probably it will be the same for ET. Ah, interesting.
ET
So
works, but
what language is that?
no, IT would be Italian. Is supported now. So it's interesting. But can we check?
Let's look at language codes. Estonian should be around here.
Yeah,
Okay,
it is.
it's ET.
Indeed.
All right, so maybe Estonian is supported now. That's even better.
So this would be a good chance for those who are doing Estonian. Try it. It should work. I'm sure LT should work. Let's try it. But do maybe text only first 100. Don't do all. Do. So we're not going to go through all 100,000 tokens. We're just going to try it first 100.
So, well, Lithuanian language as well. It works. Of course, it doesn't make sense to run it through Latvian text, but you can take Lithuanian text and try to lemmatize it. Okay, good. We found something new and useful. Now, how are we doing time-wise now?
We have, I think, about 10 minutes,
About 10
14
minutes.
minutes, so you can have a chance to work on your. Maybe we'll give a chance to work for or participants work on their own corpus.
Okay, so please look at the end of this notebook, and there's text that it's now your turn. Take some text, either from Nltk or from our corpora that we have made available here in this GitHub repository, and explore it using Nltk, Simplem, well, whatever you have learned up to this point. And so how much time do we have for this exercise?
We have we have about 14 minutes, 13 minutes, and then we have coffee break, I believe.
Okay, so approximately 10 minutes
Yes,
for
10 minutes,
the
yeah.
exercise. So now you write code and we relax. And let us know if there are any questions, if something doesn't work or you need some assistance.
This method of kind of finding words in concordance with different versions of I, let's say like in Riga, does it work in this kind of if I want to find not only E with this dash but different E's, like yesterday we were seeing that in the concordance lines would identify different versions of Riga.
Ah, like we had Riga in different declinations, right?
Or for example, versions, I don't know, maybe it was an English newspaper and it's also Riga but without this.
In the dispersion plot, like if you put in square brackets like Riga, it will just look for that exact thing. So
But
there
the
you go.
concordance line, I think it also doesn't work, at least in a simple way.
Yes, so in concordance, I guess, well, one thing is you could lemmatize that text and then you could look at concordance, but this lemmatization, it makes more sense probably for this dispersion plot as for concordance. So let's see, where's our text? That's our text new. Text new concordance.
But it's the same on conjugation or constant for different cases of the same word, it's also the same. But then maybe regex is better. Regex should work in concordances too.
Regex, well, we should check. It's not clear without checking that regex space regular expressions work as a parameter for a function. So you should check that if that's true or not, or read the documentation.
For example, if I want to find just a part of the word, which is sometimes very
Mm.
It's just two different questions.
So, for example, okay, let's look at concordance of Riga. In this case, we already have lemmatized this text. So we will find Riga or Riga, but since it's been lemmatized, this text doesn't make that much sense. Maybe we have lost all these cases, all these declinations. Baltic, how do you get long I here?
Yeah. So of course it's in English, so we have to do Shift Alt, right? We go to Latvian, and now it should work. So yeah. Oh, sorry, not I, E, right? Okay.
Okay. Now we have concordance for Riga, but in this case, so it's already been lemmatized. What if we want to work with the initial text and see if regular expressions are supported in concordance?
That's a very good question.
We have this text variable, I believe. Yes. So that's the text before it was lemmatized. And let's look for concordance of Riga first. It's been lowercase, but otherwise it's the same text. So Riga is Riga, Arena Riga, and so on. What if we want to have different endings of this word? Riga, Rigu, and so on.
So regex works?
We will check that, and it doesn't work. So sorry, this way will not help you. So regular expressions don't work here for concordance.
But let's see. NLTK is quite popular. Let's try our friend Google, right? Let's try NLTK concordance. Regex search. Maybe there is an option somewhere. Let's try see.
Because in R it's definitely there.
Yeah.
So if R has so
Yeah.
Mm-hmm.
Yeah. That's this is like 8. This is last 8 years ago. Yeah. Because we use another at the library, we have another project where it is possible to search. And that project has been written in Python, but it's not using NLTK, it's using something else.
What library is that?
I think it's just custom made, I believe, right? So.
Do you want to show, or shall we switch or not at this point? Well, so it does not work. Regular expressions don't work here, but the concordance function is not that complicated. So you could look at NLTK source code. It's available as it's an open source project, and you could modify it or write your own function that works with regular expressions. So yes, there's no clear answer. Okay, it works. It's a type of answer. Well, you can build your own, or you can modify the existing code. So NLTK concordance. So NLTK text module. Let's say search for concordance. Well, so yes, you would have to build your own in this case.
Yeah, we have a question about Colab and Google Drive. We did this yesterday, but it's still an actual question. How do you connect your drive? You basically use.
Let's switch.
Yes, I guess I'll switch. Right. So I guess I'll show it again. We had the question how you want to access your own corpora, right? Then you have it on your Google Drive, right? So again, I keep. Where is it by? I'll copy the drive. No, was it? Artists helping. I forget. There's a. It's a two-liner. No, is it? No, I forget now which was the key here. There we go. You go to Files, and there was a connect this link. Mount Drive, and it will connect. It will mount my Google Drive for the account I am connected right now. This is not my primary account, but so I will mount Drive, right? So this cell, you need to run this cell here. From Google Colab import drive mount, right? And it will ask for permission, of course, right? Permit this notebook to access your Google Drive, and it connects, right? And I'll say, okay, I can use another account, of course, right? And you have to give all the permissions, of course, since these are both Google products, right? It's just safe as, if you trust Google in one item, you have to trust another item. So, and then you will have a nice little folder, right? It will be called as drive. Okay, so let's check. There you go, right? On, so on, and you find your own corpora, right? On, and you can say, for example, here I believe this was Alice, I believe, in Wonderland, I believe. I don't know, we'll check. Copy paste, right? So let's say you have a corpora, it's just text file, right? How would you do? You're connected, right? So you want to read it with open pass, right? Control, right? Content, and it's drive. Content is not needed, right? I believe like this, right? Yeah, drive, my drive, right? And encoding UTF-8, just in case. I'm not sure if it should be as if. This is from Project Gutenberg, I believe, if I remember correctly. And basically text equals fread, basically, right? Let's see, length text. Let's see if this works. I forget if it worked or not. Maybe there are encoding issues. Yeah, there's Unicode decoding. It looks like, again, some weird format. I think it might be from 90s, right? So again, Windows, I guess we'll do again Windows 1252, if I remember correctly. I don't remember now correctly. Is this it? Yeah, it worked actually. Yeah, I think it's. What did I download actually? So text. Let's take a look. Right. Okay, chocolate and cacao recipes. Okay, great. It's a cookbook from 1908, I believe, right? So, okay, so we can again. So how would you? Okay, you have a text file. So how would you do it? So you would, again, in your language or any language, you would need to tokenize. So you have text. You start from the beginning, right? You have text. So you need to generate, convert to this text object. So first you would want to tokenize, right? You would want to do this. Right, you tokenize this text, right, on basically, right, tokens. So tokens would be word tokenized X text, right, then tokens. We're going to, of course, normalize and lematize, of course, but I'll just do tokens, right, 32,000, and then, of course, cookbook would be Nltk text, right? On tokens, right? I believe it's correct, right? And then we can proceed. Yeah, it worked, right? And then we can count cookies. Cookbook count cookies, right? Just one, of course. Just one, maybe cookie 0. Strange. Again, so cocoa, chocolate. So we didn't lowercase. Yeah, we didn't lowercase, so of course. So this would be 189. So we probably want, before we tokenize, there is no lowercase, right? So we probably want to do this lowercase, right? Again, we'll do this in the next session. We'll do something very similar. So lowercase, right? Lowercase. We'll do this over and over. So text lower, very typical, right? And then text lowercase. Lowercase, right? And same thing, like this. Okay, quite a bit of chocolate now. Okay, great. And of course, again, lemmatization would be another step. So again, it should work, right? Now we can do cookbook dispersion. And we're going to provide a list, right? We're going to have milk, cookies, right? Cookie, right? Chocolate. What else? Water. I'm sure every recipe needs water. And something else. I don't know what else. Okay, so for now, cream. Okay, something like that. Okay. Text object. When it work? Let's see. Dispersion. What was it? Dispersion plot. Sorry. Yeah. Dispersion plot. So. Yeah, it works. So milk, cookie doesn't exist. Apparently, we didn't lemmatize correctly. And chocolate is everywhere, pretty much, because again, these recipes are from the same book, of course. So the order, this is 120-year-old cookbook, right? So water and cream is everywhere as well, right? So yes. Okay, I think it's actually a good time. That's why, of course, it's time for a break, right?
Yes.
So yes. So what I'll do is I will commit this. Do we have any? Only thing, there's one ugly cell which had a big error message before I commit this to our GitHub. So again, I hope this showed you how easy it is to add your own Google Drive. Again, so whatever you save, if you save these results to your Google Drive, of course, they will persist to your Google Drive. You can use it from anywhere, any other place you use your Google Drive. So that's why it's quite nice. It's only a 2-liner to load up, and like I showed you, this part here, right? Very easy to, you just click this button, you have this example how to load it. So, okay, and I will commit, but where is the error message? I want to delete those because those were, it will just needlessly add, you will get a lot of error messages. Did you clean this up? When we got that huge error, all this.
Maybe I cleaned it up.
Okay, okay, I'll submit.
I just submit. Yes.
Yeah. So this is if those who are doing it locally, you will need to download or git pull locally in a minute when I have this submit. Okay, and now so all changed. Now I have persisted. Yeah, so this all stuff we just did is now publicly available. Again, yes. All right, thank you, and we will continue in 20 minutes. Right?
Yes.
I'll stop the recording. So again, these recordings, I will upload recording today, actually.